Hello my friend and welcome to OK Mavin, the one-stop junction for your technical enlightenment. I hope that you have gone through my previous video in which I have explained the intricacies involved in the PID tuning of drone. If you have not watched it yet, I would highly recommend to go through that video first. In this video, I'll be showing you how to implement the PID tuning concept using PID tune package and plot juggler tool. I'll also be covering the proper steps to follow to write a modular code in Python. Like this video and share it among your friends if you find this video insightful. Make sure you subscribe to this channel if you wish to see more such content in the future. Post your queries and doubts in the comment section below. The first and foremost task is to write a bug-free Python code for the drone maneuver. Now how to do that? Well, make sure you have included all the subscribers and publishers properly in your script. Then you will be running the PID launch file in the PID tune package, which you must have cloned from the GitHub, and this has been provided by eyantra to all of you guys. Now use this PID tune package to find the value of KP, KI and KD. Import the required modules as per the topic format. For this, you can use the command rostopicinfo to find out about the type and format of the message published by the topic you have subscribed to. Use the PID tune to tune your roll, pitch and yaw. You have to use them subsequently in tuning the 4 propellers of your drone individually. The speed of the drone propellers is changed by using the concept of PWM or pulse width modulation. You have to devise a strategy or say a formula to use the roll underscore out, pitch underscore out and yaw underscore out in order to find the propeller speed. You don't have to worry about the absolute value of the propellers. You just have to fine tune the PID parameters and the drone will stabilize as a consequence. Make sure you constantly check your plot juggler graphs of roll error, pitch error and yaw error, so that you get an idea on how to change the parameters as per the behavior of the drone. The most important thing here is to change the sign from positive to negative or vice versa in the formula for propeller speed using PWM. If you see that the drone behaves weirdly every time you vary your KP, KI or KD parameter, then try inverting the sign and observe the behavior. Repeat this step until the desired values of parameters are obtained. Now this was all about the PID tuning, but the focal point lies in the sample time you select for running your PID script. Always remember that your PID script should not work continuously for an infinite duration. The sample time mentioned in your script, make sure that this doesn't happen. But the interesting thing here is that you're free to change your sample time as per your convenience. Now a general question might arise. How does the sample time concept actually work? Let me briefly tell you that your sample time will determine the frequency in which the error of your drone's position compared to the desired position is rectified. For a detailed description, I'll be uploading a video in the future. Now let's come to the modularity of the code. What does it mean to write a modular code? In general terms, we can say that the code becomes good and efficient. But in technical terms, it means that the program is subdivided into modules of distinct functionalities. This makes making the program discrete in terms of dependencies and makes the code look good and proper. Now coming to the PEP-8 style coding. This is a Python coding standard followed by developers to promote the concept of code readability and reusability. Some examples include: number 1, limit all lines to a maximum of 79 characters. Number 2, imports should be on separate lines instead on a single line separated by commas. Number 3, avoid trailing white space in any line. Number 4, make sure you distinguish the difference between the usage of white space and tab. Well, in Python, using 4 white space is equivalent to a tab in most of the code editors, but still, if you use 4 white space in Python instead of a tab, you might face an exception called indentation error. And to avoid this error, I'd suggest you make sure that whatever you have used, whether it is a white space or a tab. I'll cover PEP-8 in greater detail in subsequent videos. I think this should be enough as of now. Good luck to you and your team, and remember, if the task doesn't mess with your mental peace at any point, then you are doing it wrong, my friend. So, do not give up or lose hope. Okay, Mavin, over and out.